Hey everybody, it's Monty, and we're going to finish our first foldable, okay? So we folded it, and we did these perfect squares the other day, and now let's open the page, okay? And we're going to multiply some radicals, and then we're going to see if we can divide some radicals. All of this work is because we're focusing on our cheat sheet, getting ready for trigonometry. SOHCAHTOA. All right, so we've got their foldable out. All right, here we go. So the other day we talked about how it's okay to rewrite stuff. All right, and what we mean by that is if we multiply 4 times 2, 4 times 2, that's the same as multiplying 2 times 4. Well, sometimes it's convenient to realign everything, okay, to rewrite it. So now, the coefficient is the stuff on the outside, 2, 5. So I'm going to rewrite that, okay? So I'm going to write 2 times 5. And we all know what 2 times 5 is, okay? Now, I have the square root of 10 and the square root of 5. Well, we saw the other day that it's okay to rewrite the square root of 36 as the square root of 4 and the square root of 9. Serious. Or we can rewrite that as the square root of 6 times 6. All of these are legal, okay? The answer to this is 6. The answer to this is 2. The answer to this is 3. The answer to this is 6. And 2 times 3 is 6. Okay, so now I'm going to put these together. We could. Okay, let's put them together. First of all, we know 2 times 5 is 10, but I'm just going to leave it like that. And on the inside, I could write the square root of 50. Okay, I could. But we want to simplify. What are numbers that multiply to 50 that might be perfect squares? Pause the video, take a look. Here's our goal. Our goal is to get 2 times 5 times the square root of 25 times the square root of 2. Can you see that 2 times 25 is 50? And we know the square root of 25 is 5. Okay? So now we have 2 times 5 times 5 times radical 2. Final answer, 2 times 5 times 5. 2 times 5 times 5. 2 times 5 is 10. 5 times 10 is 50. Okay. Now there were lots of different ways to massage the square root of 10 times the square root of 5 to get 5 radical 2. Alright? So now pause the video and then come on back when you're ready to discuss what the possible answer is here. Okay? See you in a minute. Alright, welcome back. Hopefully the first thing you did was see that this is a negative 1 and a 3. Okay? So, negative 1 times 3. Now, we got a bunch of stuff to do here. Okay? Now, my recommendation is to massage each one independently. Okay? Because if we just take 12 times 32, 12 times 32, we get 384. Well, the 384, you know, we got a big factor tree to build, right? 2, 192, 2, 96, 2, 48, 2, 24, 6. Wow, final answer is going to have a 6 for sure, right? That's something. But what if we did this instead? Things that multiply to 12 that have perfect squares. Okay? So when I think of 12 and I'm looking for a perfect square, I think of 3 times 4. And I'm going to write it square root of 3, square root of 4. Now, if you do these long enough, you think of perfect squares, okay? I think we'll just move that out and leave it right there, okay? When I think of perfect squares and I think of 32, I have the square root of 2, square root of 16. Now, I know the square root of 4 is 2. I know the square root of 16 is 4. So I'm going to bring that out. I'm going to bring that out. Okay, so now I bring this down. Negative 1 times 3 times 2 times 4. I still have the square root of 3 and the square root of 2. Okay? Alright. Well, now 1 times 3 is negative 3 times 2 is negative 6 times 4. Negative 24 radical 6. Pause the video and study what you did to see if you got something similar. Okay? And then we'll be back and we'll get started on the very last one. Okay? Alright, welcome back. Now, before we start the last one, we got a lot of stuff to think about here. What does this mean, first of all? Squared. Squared. That means everything in the parenthesis times itself. Okay? Everything in the parenthesis times itself. Cool. Well, I know the coefficients. Stay outside. 3 times 3. And then I have the square root of 11 times the square root of 11. Well, isn't 11 times 11 121? And 11, the square root of 11 times the square root of 11 is the square root of 11 is 121. So I got 9 square root 121, but I know the square root of 121 is 11. So I get 9 times 11, so I get 99. All right. Pause the video if you need to. But now we want to have us study dividing radicals. Okay? All right. Now, dividing radicals. I know we all love division, right? There are some special things we need to study here. Okay? All right. So the first thing is, let's look at the coefficients. Divide and reduce the coefficients. Well, that's easy. 9 divided by 3. 9 divided by 3. How many times is 3 going to 9? Okay, I'm going to rewrite this. 9 over 3, square root of 24, square root of 2. Okay, so first we know 9 over 3. Okay, 9 over 3 is 3. Okay, but this part is not as easy. This is not as easy. We got to study this, okay? Now, we know that anything divided by itself is 1, like 3 divided by 3, 3 divided by 3 goes away, and we get 1, okay? Can we rewrite the square root of 24 in terms of radical 2? Can you see how I can write this as the square root of 2 times the square root of 12? Square root of 12. So I can rewrite this, can't I? Square root of 2, square root of 12, over the square root of 2. Well, remember, anything divided by itself is 1. So I'm left with the square root of 12. Now I know this gets messy because I've got a 3 over here, and I've got a square root 12 here. This actually reduces down to 3 radical 12. Okay? All right, now comes the fun part. I know everybody in here loves to simplify fractions. Okay, so we have two things going on. We got the 18 and we got the 24. And some of you are already seeing the square root of 35 is the square root of 5 times the square root of 7. Good. So now we have the square root of 5, square root of 7 over the square root of 5, and you're already seeing that the square root of 5's go away. All right, but before we go any further, let's do our factor tree. Things that multiply to 18. 2 times 9, 2 times 3 times 3. What are things that multiply to 24? 2 times 12, 2 times 2 times 6, 2 times 2 times 2 times 3. Okay? Now if I rewrite all this, I have 2 times 3 times 3, and 2 times 2 times 2 times 3. Okay? So what did I do? I had the number 18, and I factored it. I had the number 24, and I factored it so that we could simplify. Okay? 2 over 2, 3 over 3. So what do I have left? Let's get a different color. Square root of 7, 3, 2, 2. Let's clean all that up. 3 radical 7 on top, and a 4. Okay? And this is why we're calling this Skill Builder Week. Okay? Because all we're doing is practicing skills. Okay? We need to practice our math skills. So Skill Builder Week. Alright? So a lot of math, but it's just like in our English class. We got all that punctuation. Do we need it? Well, it helps make sense of the words. All these skills help make sense of math. Alright. Now what we want to do is have you try a couple of problems. Okay? So now we've filled in all of multiplying radicals and part of dividing radicals. Okay? If we have time today, we're going to rationalize. But right now, we'd like to pause and have everybody in class try these two problems. Okay? We'll see you in about 5-6 minutes. All right, here we go. So, first thing we need to do, outside, 6 times 9, square root 7, square root 2. 6 times 9 is 54. This is a prime, this is a prime. Square root of 14 is not perfect. Done. Did you get that? Okay. First thing we do is the outside. 5 over 10 is nothing more than 1 over 2. Square root of 24 is the square root of 8. Square root of 3. 3's cancel. Let's just write it out. 1 times 5, radical 3, radical 8, all over 2 times 5, radical 3. 5 divided by 5 is 1. Radical 3 divided by radical 3 is 1. Final answer. Radical 8 over 2. Can't go any further. Radical 8 is its own little beast, isn't it? What's that? You went further? Radical 8 is the radical 2, radical 4, let's just put that over 2, over 2. And then, nice job, you guys saw perfect square. 4. The square root of 4 is 2. Alright, so this becomes a 2. So now we have 2 radical 2 over 2. Cancel the 2's. 2 divided by 2 is 1, giving us our final answer, the square root of 2. Alright, nice job. Okay, now we've found a square root. Thank you, Miss Perrier. Alright, now, depending on the time in the class, we might discuss rationalizing a radical. Okay? In math, we don't like this. Okay? We don't like this. We don't like square roots in the basement. We don't like square roots in the denominator. And there's an easy way to get rid of them. Okay? So, depending on the time in the class, we might get to this, or because this week it's really important that we get to Mathia, we want to make sure that everybody logs into Mathia, because that's going to be classified as our Friday quiz this week. Okay? So, we got the front, we got the back, we multiplied, and we divided. Now this bottom part, if you have time, great. If you don't, that's okay too. So, what we're going to do now is maybe come back to rationalizing, because I want to make sure everybody has a chance to log into Mathia. But the key to success is reduce the coefficients. 12 over 4 is easy. Divide the radicands. That's easy. But we need to simplify if possible. No radicals left in the basement. Okay? So, this is going to be what we do. We multiply the square root of 2 over 2. We know that anything divided by itself is 1. We know that the square root of 2 times the square root of 2 is 4. The square root of 4 is 2. So, 12 radical 2 over 4 radical 4. You see how this can go away? And now, as mathematicians, we're happy. Multiplied by the square root of 3 over the square root of 3. That's nothing more than a 1. We know that the square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. Okay, so now we have 10 radical 3 radical 5 over 2 radical 9. We know that's a 3. Okay, so this is called to rationalize. Okay, to rationalize. All right, and if we have time, we'll come back and work on these. Okay, we just did the process of. All right, so thanks for doing all that. We've got a couple of minutes now left on this video, and I want to make sure that we all can get to Mathia. So, everybody, let's go to the internet. Okay. And once we get there, we're going to do some Spokane Public Schools. And then we're going to go to our data tools. And once we do digital tools, we go to Clever. Log into Clever using our email address. Once we get into Clever, we got to find the CL, the Carnegie Learning, the Mathia button. Okay? And some of you, I'm sure, don't bookmark it, but if you go down to Math, you'll find the CL, Carnegie Learning Mathia. Click on that. And then, once we're here, we got to click on our Mathia button. Okay? So, everybody click on the Mathia button, not the textbook. And this week, we're working on this thing called special right triangles. Okay? So, everybody find the box that says special right triangles. Okay? Now, this is an added item, so it should be labeled number 4. And we want to go look at special right triangles. Okay? And we're just going to review it, and then we'll calculate. All right, so 45, 45, 90 and a 30, 60, 90. Okay? Now, on the back wall and on our cheat sheet, we have these rules for special right triangles. Okay? And when we practice these, all we're doing is trying to avoid having to do the Pythagorean theorem over and over and over and over. Is there a faster way? Well, it turns out there is. We know that a 45, 45, 90 was a box, was a square. And all we do is multiply by radical 2 to get the hypotenuse. Got to memorize that vocabulary. Or divide out radical 2. Okay? So in this first one, JK is just 8, click, radical 2. Then I've got to go outside, slash, and we're going to divide it out. Just get rid of radical 2. Okay? That's all it is. We divide when we go out, and we multiply when we go in. Well, 45, 45, 90, this is a box. It has to be 8. 8 by 8. It's a square. Okay? Now, this one's a little harder. We divide out radical 2. No, it's not harder. Just go 12 slash radical 2, done. Okay? And RF, it's a square. If it's a square, it's just the same answers. 6 radical 2. All right, I'm going to do one more here. Soren flies a kite on a beach. The string forms a 45-degree angle with the ground and is let out 16 meters. So we got the kite up in the air. He's standing down here, and he's up 16 units. The string is 16. 16. Divide it out. Literally, just divide out. 16 slash radical 2. Okay. And bag of potato chips. Now this can be kind of confusing because, right, we've got this triangular potato chip, right? Got a potato chip, and it determines that the long side of the potato chip and the bag is 3 centimeters. I apologize for this. They should not have used the word longest side because in math that's called the... Come on now. What's on that back wall? Hypotenuse. And whenever we have the long side, divide out. Divide out. Okay? So this is what I'd like you to do for the remainder of class. Area of a potato chip. Whoa! Whoa! Monty told us the area of a triangle. 1/2 length times width. 1/2 length times width. If this is 2.12, this is 2.12, multiply, divide by 2. Now, grab your fraction maker. 2.12 times 2.12, toggle down, divide by 2. Isn't that cool? Now, Prospect Park is square with side lengths 512. One path through the park runs diagonal to the northeast corner and divides it into a 45, 45, 90. Huh. Well, that's what we've been doing, right? 512, there we go. 512, 512. Divides it. How long is the diagonal? What's this called? The hypotenuse. 512. What? Come on now. Multiply by radical 2. Multiply by radical 2. Multiply. Oh, too many multiplies. Done. All right. So now, that's all that first one was. Go to the next one. Okay. This is 25 minutes in class. You're going to go a little bit slower. You got to find your stuff. Hopefully you had a great day. Next week we got to wrap up our special right triangles. Okay? So let's have a great day, everybody.